EVs with a heat pump need up to 50% less energy in cold weather. In this video, we'll cover why it's recommendable to buy an EV that has a heat pump, especially if you live in an area with extreme temperatures, both hot and cold. We'll dive into the rise of batteries, the temperatures for which heat pumps are important in EVs, and what difference a heat pump makes in the range of the vehicle, the electricity savings, and the battery life. I'm Kata. Welcome to Net Zero Tech. Before we dive into the functionality, benefits, and manufacturers for heat pumps in EVs, it's worth noting that both heat pumps and battery sales are undergoing a massive rise. Characterized by an S-shaped growth curve, battery sales have been doubling every 2 to 3 years for 30 years now. Since electric cars have gained momentum, battery sales growth has been closer to 40%. The increase in sales is driven by the developments of decreasing upfront costs and increasing battery density. For every doubling of deployment, battery costs have fallen by 19%. Couple these cost declines with a density gain of 7% for every deployment doubling, and batteries are the fastest improving clean energy technology. Battery sales will continue to grow a lot faster than today's consensus view. Most battery forecasts keep effectively projecting linear growth, while the battery sales are actually growing exponentially along a classical S-shaped growth curve, typical for disruptive new technologies. Now, there is a sales curve that looks somewhat similar. It's the one for heat pumps. Of course, most heat pumps are used for heating and cooling industrial, commercial, and residential buildings. However, there's a use case where both technologies meet: EVs. So why are heat pumps important in EVs, especially in extreme temperatures? I think it all comes down to costs, both upfront costs and running costs. Batteries are more of a commodity than EVs, and both will further decrease in price elasticity over time. You could say there is a practical advantage of heat pumps in EVs for the user, which is increased range. However, that ultimately comes down to costs as well, since you could simply put a larger battery into a vehicle to increase the range. However, that would again result in both higher capital costs and operational expenditure. So adding a heat pump increases the range of your electric vehicle, particularly during the winter months. When an electric vehicle is switched on in the winter months, it takes a while for the battery to warm up, which reduces the efficiency. Lithium-ion batteries in an EV rely on chemical reactions to store and create electricity. Cold weather slows down these reactions, resulting in the drop in performance and range. It is estimated that an EV range drops by around 10% in the winter, even before you account for using extra energy for cabin heating. Heat pumps can really help reduce that drop-off. Cars with heat pumps are also proven more efficient, averaging 3.2 miles per kilowatt hour compared with 2.9 miles per kilowatt hour to the ones without. The more extreme the temperature, the more a heat pump contributes to efficiency and battery life. Even with these new advances, freezing weather isn't a heat pump's friend. Efficiency will drop if you get to really cold temperatures. But compared to electric resistance heating, the heat pump cuts the need for energy for heating fairly significantly, maybe by 2/3 or so, depending on the outside temperature and the efficiency of the heat pump. Today, heat pumps come in many, but not all electric vehicles. Heat pumps are becoming increasingly more popular everywhere, including electric vehicles. There are quite a few affordable EVs with heat pumps. For instance, Nissan Leaf, Hyundai Kona, Chevy Bolt, Toyota Prius, BMW i3, Kia Niro, Audi e-tron, etc. Some brands, such as Tesla, Porsche, and BMW, offer EVs with heat pumps as a standard. Some manufacturers offer a heat pump as an optional extra, and frustratingly, they can be a pricey addition. Teslas have come with a proprietary heat pump technology since 2021. Jaguar's I-Pace has one built in, as does BMW's latest series cars. Hyundai Ioniq 5, Audi's newest e-tron, and Kia's electrified flagship, the EV9. The Enyaq by Skoda and other EVs offer a heat pump as an optional. Heat pumps are often included in the kit list for higher trim levels of many models. All new Tesla EVs come with a heat pump as a standard nowadays, and this makes a big difference when it comes to cold weather efficiency and range. Tesla cars equipped with a heat pump can use heat generated by the battery and drive units to warm the cabin, save energy, and improve range on long drives. As with many aspects of Tesla's cars, engineers adopted a unique approach when designing the heat pump. The company opted for a fresh design when implementing the technology, going through many iterations during a process of trial and error. Tesla's heat pump features several innovations, such as the super manifold and the octo valve, which help increase the heat pump system's efficiency and integration. For example, in really cold weather, where other heat pumps fall short, Tesla's system can generate its own heat to keep the cabin warm and prioritize power. Another priority for Tesla when designing the heat pump was to reduce complexity, and the team achieved that by thinking outside the box. For example, engineers needed a new configuration for the coolant loop, so they combined two valves into a single valve while at it. Additionally, the adoption of the super manifold enabled Tesla to significantly reduce the number of components. This made the heat pump easier and more cost-effective to build, as well as potentially more reliable, since there are fewer components that can break. The Nissan Leaf was the first mass-produced vehicle in the world that used a heat pump system. They have built it in since 2013, but only for cabin warming. Looking at 5 years of battery degradation of two EVs that have collected years worth of data, the 2015 Tesla Model S and the 2015 Nissan Leaf, the Leaf suffered from an average degradation of 4.2% over 4 years, while the Model S only has 2.3% degradation over the same time period. The Tesla has a superior thermal management system in place that uses liquid to cool the battery as opposed to air cooling with the Nissan. To maintain battery health and reduce degradation, you can keep the state of charge between 20 and 80% and reduce fast charging as much as possible. And don't be afraid to drive your EV. High use did not correlate with an increase in battery degradation. Several high-mileage Teslas, like the Model S, have passed 1 million kilometers. We used to own a 2017 Hyundai Ioniq Electric and now own a 2012 Nissan Leaf and a 2022 Tesla. I'm quite happy with all of my EV purchases, but I have to admit that it is quite comfortable to warm up the Tesla using the app before driving the kids to school during cold winter mornings. Thank you so much for watching. I really appreciate it. An extra big thank you to Bill Eastman, who joined as the first non-family Patreon member. If you'd like to learn more about battery banks, this can help. If you are interested in why I think fuel cell vehicles are likely not the best way to decarbonize passenger vehicles, this is for you. Have a wonderful time and see you in the next one.